Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, I'll describe significance levels. The researcher must do their job to eliminate as many potential sources of error as he or she can. We do this by selection of large and representative samples, by random assignment to groups, or through accurate measurement. But there are still things we can't control, and there's always going to be error. We must define our significance level. We usually use alpha to denote the significance level. It is a probability value, so it ranges from 0 to 1. 0 is impossible, and 1 is 100% chance or certainty. The significance level is the level of risk we're willing to take that we will reject a null hypothesis when it is actually true. That is, it's the risk or probability that we will make a type 1 error. By choosing the alpha level of 0.05, I'm setting my level of risk for a type 1 error. You determine this ahead of time and then you do your statistical test. I decided I would accept a 5% chance that I would reject the null hypothesis. The significance level is going to provide the criterion or the threshold for rejecting the null hypothesis in a statistical test. So your decision to reject or to retain the null hypothesis is determined by your significance level. So what specifically does it mean when alpha equals 0.05? 0.05 means that 5 times out of 100, your sample statistic will meet that critical value you get or a more extreme value, given that the null is true. So, for example, if the null hypothesis is that a population mean is 0, by choosing an alpha of 0.05, this means that 5 times out of 100, our sample statistic is going to say that there is a difference between some observed value and the population value, even though there's actually not a difference. 5 out of 100 times is pretty small. It would be rare or an unlikely occurrence to get that value if the null is actually true. If we meet or exceed the critical value threshold associated with an alpha of 0.05, we're going to assume the null is false in the population and we will decide to reject it. In other words, we think that there is a true difference between our teachers and the population, in our teacher boldness example, that is not due to chance. But 5% of the time, we will reject the null hypothesis when it is actually true. We know that we won't always be correct in our decision to reject the null hypothesis, and so we pick the level of risk, that's alpha, that we incorrectly reject it. We typically use a significance value of 0.05 or 0.01. But what do those numbers stand for? Another way to think about the 0.05 significance level is that chance alone would produce a result as extreme or more extreme than the critical value only 5% of the time, or 5 out of 100 times, or less, given that the null is true. So what does 0.01 mean? It means that chance alone would produce a value as extreme or more extreme than the critical value 1% of the time, given that the null is true. So if chance only gives us a value that is as extreme or more extreme 5% or 1% of the time, if we obtain a value that is as extreme or more extreme in our sample, we assume that it is not due to chance, that we're finding an effect when there really is one. So we would think that that value is too rare to be an error when we set our significance levels so low. So in sum, this significance level sets a threshold. If we compute our statistics and it exceeds that threshold, then we say that we reject the null hypothesis. If we're really worried about the possibility that we will reject the null hypothesis when it's true, then we could decrease the probability of type 1 error by using a smaller alpha level. That would minimize the chance that we would incorrectly reject the null hypothesis. We could, but there's a trade-off with type 2 error. The error of not rejecting the null hypothesis when it's actually false. If we decrease alpha, we increase beta. And the reverse would be true too. If you were to decrease alpha, power would decrease too. This is because if we decrease alpha, beta increases, and thus 1 minus beta decreases. This concludes the lecture on significance levels. In the next lecture, I'll describe the steps of null hypothesis significance testing.